was quite interesting hearing what people say the regulators will and won't do. And I think with carbon capture and storage, there's some things that we just don't know yet in terms of regulation. So you may have recognised the words of the title, which are from a poem by the former Secretary of Defence in the USA, Donald Rumsfeld. I think he didn't realise he was a poet until somebody wrote down what he said, so I'll just illustrate that in relation to CO2 capture. So I'll start off talking about background and legislation and our point of view, and who has to do what. So a lot of it we know, but there are some roles and responsibilities that we're just not really aware of yet, or we don't know who's exactly going to be doing what. And then I'll move on to the monitoring itself and what we do and what we're looking for, covering carbon capture, but then transportation and storage. And I think we've heard a lot about details of what we could do and how we could monitor everything to death. I'll say at the outset what we're looking for is a risk-based approach to monitoring, because there's always going to be uncertainties we just can't achieve yet. There's always going to be residual risks we're going to have to live with. So I'll talk about what we'll expect in terms of those risks. I'll cover what we know, also what we don't know, or what we do know about what we don't know. That's growing all the time. But fortunately, we are learning as things go along. And if we go back, say, 10 years to when the incineration directive was in its early days, there were a lot of standards that didn't exist, and there are a lot of things that we just didn't know if we could monitor them at all and quantify what emissions were. And now we do. So I think in 10 years' time, we're going to hear quite a different story regarding monitoring and measurement of carbon capture and storage. We've really been able to do that by a lot of research and standardisation and applying the 80-20 rule to monitoring. And I predict that we'll be able to do the same with CCS. So just going on to Donald Rumsfeld's poem, you may have heard this on Radio 4 years and years ago, and apparently nobody knew it was a poem until they wrote it down. And the gist of it is, when he was talking about weapons of mass destruction, is that there's always things that we definitely know, and we know them. And then there's things that are unknowns, and what he called the known unknowns. And so we know what we're looking for, and we have to find them, and usually we do. And then there's things that we don't know about that we don't know, and those are the things that worry me. But we won't find out until we've discovered them. And somebody mentioned nitrous amines in relation to amine capture and degradation. We didn't know those existed till someone discovered them, and now there's quite a lot of research effort to quantify those. And so that was an unknown that we know about. So I'm sure there's going to be some that we find out about in a few years' time. The legislation itself, I'll just whip through this without quoting in too many articles or particular bits of legislation. So the main one is the CCS directive, which we've heard about. There's also, let's not forget, the Industrial Emissions Directive, which does have provisions for carbon capture in it as well. In the UK, we sort of preempted the CCS directive, and we included our implementation of it through the Energy Act, and then more recently the storage of carbon dioxide licensing regulations in 2010, which doesn't actually say who the competent authority is, although we know in the UK for offshore it's going to be DEC. For England and Wales, and in Scotland it will be Scottish ministers, although the Environment Agency and SEPA will have an interest in what happens. And we have the storage of carbon dioxide inspections regulations from this year, which talks about what's going to be needed in terms of inspection, but it doesn't actually say how, so it's up to us to find out the how part. And then the environmental permitting regulations, certainly in England and Wales, will be updated to include more provisions for carbon capture and storage, and we already have quite a lot of those in place already. I think related to that, we had the CCS roadmap from last month, and in terms of monitoring, that talks about developing accounting procedures and specifying standards for CO2, so that covers both measurement and standards of CO2 in pipelines. We have to establish common measures for monitoring and measurement, so we have a lot of tools available already. We don't know exactly how we're going to use those. then we need to know that they actually work. So we want validation of capture technologies and storage technologies. And in particular, demonstrate low-cost and sensitive CO2 monitoring technologies. I think I really like the idea of submarines with monitoring technologies on them. But in the long term, I don't know how practical that's going to be, and I think certainly we'd need those for research. But what we want to see is something that's going to give us, say, the most data for the least cost. The government wants us to develop commercially available systems with very high efficiencies. So that's high efficiency of capture and very low energy use, or what's called the parasitic load. So what are we doing? Well, the first thing we do is that the capture plants that do exist and the ones that will exist, we give them permits. We're also the competent authority for the EU ETS, so in that we issue allowances and we administrate the NER, and we also manage the registry as well for allowances. We have quite a significant advisory role in the ETS, both nationally and internationally. We have one of our team permanently in Brussels at the moment working on the new guidelines and regulations. We have quite a lot of input into the monitoring and verification procedures as well. So we have an overarching interest in valid monitoring techniques and sound verification. Why are we so interested in that? Well, I think a lot of it is really down to not so much the price of carbon, but the underlying asset, or CO2, which forms the, say, derivatives such as carbon futures and allowances. Because carbon capture and storage just isn't going to happen unless it's going to be economically viable. So a lot is down to the price of carbon, but moreover, how accurate the measurement of those underlying assets are. So we have a very strong interest in accurate and precise measurements of carbon dioxide. In terms of permitted capture plants that exist, there's two that we're strongly involved in and that we've permitted, and they're both post-combustion capture technologies, and they're for research and development and mini demonstration projects. And I think whilst we wouldn't advocate monitoring, say, a full-scale system to death, we would want to do that in an R&D and a demonstration project, simply because the more we know, then the more we can get away with not monitoring, because it's very easy to go beyond the 80-20 rule, and that immediately ramps up the expense, and that means something isn't going to be financially viable. Two plants in particular, there's one at Ferrybridge, which is owned by Scottish and Southern Energy, and they're involved in a joint venture with Babcock Doosan and Vattenfall from Sweden. You may have heard of that, in that it's called the 100 plus CO2 project, in that it captures, or it's designed to capture, 100 tonnes of CO2 per day. And then there's Aberthaw in Wales, which is operated by RWE, and they're in a joint venture with Cansolv, which is part of Shell. That plant is roughly half the size, in that it's designed to capture 50 tonnes of CO2 a day. And these will tell us a great deal about degradation and capture efficiency. I've shown that slide deliberately just to give you an idea of the scale of the plant. It's about 2 gigawatts, and in the foreground you can see the very large flue gas desulfurization units, and they don't look very big there because they're dwarfed by the 200-metre stacks. But behind those, there's a carbon capture unit, which is capturing about 1% of the CO2 from the plant. So if you can imagine scaling that up to full size, it just gives you an idea of the challenges of making these things full size. And then towards the right-hand side, you can see a person there in a high-vis vest, and when you're up close to it, it's a very, very large plant, and I think our minds just boggle at the thought of scaling this up to a full-size plant. So it's going to be very, very big. Aberthaw, down in Wales, is similar. It's a 1.6 gigawatt coal-fired power station, and there's the pilot carbon capture plant being built, and it's just about ready for commissioning. In the permits, which now provide for the carbon capture units, there's some very generic things, but they're specific in their application to carbon capture, in that we want a management system that's systematic and based on risk assessment and planning. That includes operational conditions and scheduled releases, or what is allowed to be released as a maximum emission. And we expect the application of best available techniques, and the permitted releases cover effluent and air emissions, and in particular amines and their degradation products. That's relevant for two reasons. I think one is that some nitrous amines, for example, are carcinogenic, but mainly in terms of, say, the EU ETS, degradation means that the capture efficiency is going to be reduced. So we need to know what that is in order to include that in carbon accounting. The monitoring requirements we have are that generically we require certified or proven monitoring systems where they're available, and a hierarchy of standards. That's down from CEN to ISO national and other national and international standards. We're missing a few, I think, specifically for carbon capture and storage, but they will happen, and there's plenty of action happening underfoot to make sure that we do have those standards. And then in terms of applying them, we require test laboratories to be accredited and to apply test methods that are in their scope of accreditation. And there's other standards that apply to the quality assurance of monitoring as well. We know by applying these that the accuracy and precision of any test methods applied are going to be as good as they can be. We apply all of these in the UK through the Environment Agency's monitoring certification scheme, which is really nothing more than just a way of packaging international standards and proven equipment. If we look at the carbon capture and storage chain, I've exemplified here, well, the example here is for post-capture technology using amine scrubbers, and it's not new at all. I think the technology's been around since the 30s. It's been used at a coal-fired power station in California since 1978, not for looking at climate change, but simply to capture CO2 for use as a feedstock. So we've got lots and lots of experience, and we know what a lot of the problems are. The big holy grail at the moment is the amine solution that gives you a high capture efficiency yet sheds CO2 very easily with the least energy input and low degradation. So there's a lot of cloak and dagger, very secretive research at the moment to try and find this perfect amine recipe. And the plants that we look at, we don't even know what those amine mixtures are, because the people involved in designing them don't want to tell us, because they're so, well, they're guarding these recipes so closely. So from our point of view, we want to know just how efficient it is, and we want to know whether there's any degradation products. And so the pilot plants, what we're looking at is monitoring what goes into the scrubbers, what comes out, what goes into the pipeline that will eventually feed into a compressor. And we've got to try and match up the two and look at different monitoring techniques and see what gives us the lowest uncertainty for the least input of cost and time and effort. And so this is where we do a lot of monitoring in the early stages so that we can minimise it as time goes on. And we've talked about quantification and detection. And what we hope to aim for is, say, something that's risk-based, where we know that the uncertainties are quantified, and if there's nothing detected or very low levels detected, then we'd be able to say with quite a high degree of confidence what the releases are going to be. And that would eliminate the needs to do masses and masses and masses of monitoring, but in order to get there we need to do quite a lot, in fact a huge amount of monitoring in the beginning. So this is why there's such a lot of research effort looking at the capture part of it, the pipeline and the reservoirs. Oxyfuel combustion, which is the other one that I would put my money on at the moment, it's a very similar story in that we're looking at the inputs and outputs and looking at a combination of monitoring and mass balance models and using the experience we've got to try and produce the optimum monitoring program. We've seen a bit of legislation. I think one to watch is the new monitoring and reporting regulation that's being written and refined as we speak. And in theory it should be published this year, and that consolidates a lot of what we know already. Without going into all the equations, in very simple terms, we look at the CO2 that's captured, and then we have to subtract the CO2 released. And what we'd want people to do is focus on the highest risk points of release. so that we're not trying to monitor absolutely everything, because from what I've heard this morning, I just don't think it's going to be practical, and I don't think the cost benefits are really going to give us that much in return, but there is a minimum we will need to do. So I think what we should know is how we can apply the 80-20 rule at the end of all the different research programs we've heard about. That equation is going to be underpinned by monitoring and valid calculation procedures, which themselves are quite often supported by monitoring. The new guideline or regulation talks about using mass balance or monitoring individual sources. I think what we see is a combination or a lot of mass balance work with, say, periodic verification by monitoring. The new regulation also includes requirements for continuous emission monitoring systems, and I think the most likely thing we'll see is monitoring for CO2 going into a capture unit and coming out of that capture unit, so that we can look at the efficiency continuously. We may be able to look at things, say, such as ammonia, which is relatively easy to monitor, and perhaps total organic nitrogen, and measure these things continuously, and that gives us an idea whether the efficiency is being maintained. And then if it's not, we could focus more on periodic monitoring for things such as, say, hydrogen sulfide or breakdown products from amines. So what we're looking for is a simple way of monitoring any degradation products that tell us a lot about the efficiency of capture. And hopefully if we don't see them, we don't need to do anything more, but if we do, then we'd envisage looking in more detail at specific compounds. Also, the regulation itself includes requirements for test laboratories, so we know that if any test laboratory is accredited and it does monitoring, then it's going to be doing it to a given level of uncertainty. Going on, it includes reference to a standard called 14181, which has been proven for CEMS in the Large Combustion Plant Directive and the Incineration Directive. It's also been used for emissions trading for SO2, NOx and for particulates, and more recently for nitrous oxide as well, so we know that it does work. There's also requirements for taking into account the energy used in capture and the other parts of the chain, and the regulation specifies uncertainties in different tiers. I think it's very easy to get completely hung up about these and lose sleep if, say, your uncertainty is 2.7% instead of 2.5%. What we say is, let's do the best that we can with the best techniques we've got available, and if we can't, then we just factor in that uncertainty into calculations, because certainly that's what we do with emissions trading for SO2 and NOx and particulates, and where the actual measurement provisions are quite often so old that we can't get anything near the uncertainties we're meant to. So we factor those into emissions trading, because that's the best that we can do. So I envisage until technology is improved, that's what we do again. I think these uncertainties, and we talked about them being difficult to achieve, they are, from our experience, difficult to achieve for low flows and concentrations, but much easier the higher the concentration gets. So for measuring CO2, compared to other things we've had to measure, we don't see that as being nearly as great a problem as we might have envisaged. So we have a lot of experience from incineration and large combustion plant directives, and from emissions trading as well, not for CO2 but for other things. In terms of degradation and loss of efficiency, I think again it's something that's been looked at for a long time. This was research from 2002, and it was looking at the plant that's been in operation since 1978, and when I first started working on this, I was just amazed how much published literature there is in this area. The early work looked at MEA as a solvent, whereas now people are looking at different solvents, and there's one plant in particular in Denmark that was part of an EU project that has really been monitored to death, and that's given us a lot of very useful information in terms of not just degradation products, but measuring the capture efficiency and also what we can and can't do. We also have standards that are being developed, for example, quantification of greenhouse gas emissions from industrial processes. There's some new standards for monitoring flow as gases, and they've been developed to include in their scope the emissions trading directives as well. So they include provisions for the ETS, and they've been validated, and we know that we can achieve the uncertainties that are required by the directive and the daughter regulations. And then there's other standards that have been proposed as well, for example, guidance on capture and storage monitoring and CO2 capture efficiency, which we see as something that will become routine, and based on our experience we think it would be quite achievable as well. I think with test laboratories, if we go back, say, 10 years, when our approach to accreditation was really developing, we've seen a massive fall in the degrees of uncertainty. In other words, monitoring has got a lot better by standardising what people do and assessing them, and that really has improved the quality of monitoring. And another driver for that is something such as the Large Combustion Plant Directive for gas turbines has very, very low emission limit values, which makes things a lot harder for the test laboratories, yet they have achieved the uncertainties that are required, and the levels of pollutants they're measuring there are just minuscule compared to the things we have to measure for carbon capture and storage. And again, in terms of degradation products and capture efficiency, we know that there's certified systems that have been proven in carbon capture work. So in terms of tools available, we're actually quite confident we've got a lot already, both in terms of continuous monitors that can easily be extended to this field, and test laboratories as well. I mentioned EN 14181, which is the standard for quality assurance of continuous monitoring systems. That is prescribed in the new M&R Regulation. And this is something that I scribbled a few years ago to explain what 14181 was about to some relatives, because if you've looked at the standard, it's not really written in English, it's more technical speak. And we were just having breakfast, and I got the back of a Shreddies packet and wrote this down, and I said, "So do you understand it now?" And my relative said, "Yes, but I think people that write standards should eat Shreddies more because it's a lot clearer that way." And in very simple terms, it says that you should buy some suitable equipment for monitoring that's proven, and that's called Quality Assurance Level 1. It has to be set up correctly in the right place, it has to be calibrated, and then you ensure it stays working correctly. And this is all bound up in levels of quality assurance known as quals, and there's an annual surveillance test as well. But the underlying principle is a risk-based approach based on planning and avoiding problems before they happen. And we know that the uncertainties that are specified are quite easily achieved when applying this. So I think this is a reason why it has been applied to emissions trading. And as we speak, it's probably being used right now for the combined development mechanism in the N2O abatement plants have to have CEMS, and these CEMS have to be quality assured using 14181. So there's a lot of experience already in applying these standards to emissions trading. And as I mentioned, we apply them as well to SO2, NOx and particular trading. So just to sum up, what we know we know how to measure CO2, and we know how to measure the composition of stacked gases and effluents to the required uncertainties. And that's in terms of the individual tools and techniques and equipment that we can use. If we haven't got everything we need, we also know that existing techniques, methods and standards can be adapted or developed based on past experience. We also know that monitoring with CEMS and applying 14181 does work for emissions trading, because we're doing it now and we have done it. But also we know that amines can degrade, and that will in turn degrade the capture efficiency of capture plants, which again will have a big impact on allowances and trading. We also know who will regulate most parts of the CCS chain, but it's just a case of deciding what the details are in terms of pipelines and what role exactly, say, on land regulators will have offshore. We also know how to measure flow in liquids and gases, and we've heard there are challenges ahead, and I'm sure we'll find a way of solving them, perhaps not tomorrow, but based on experience we will do. We've also got a lot of experience of measuring flow in liquids and gases in other fields, and certainly in monitoring. What we've done is look at what people have done elsewhere and adapted those to what we need. The unknown or known unknowns is exactly how we'll tie this all together in an integrated procedure for whole system CO2 accounting. And as I mentioned, there'll always be a residual risk, and it's a case of just deciding what we can live with and then including that in any accounting. And I'm sure, based on our experience, that uncertainties will get lower as time goes on. We also know how CO2 behaves or doesn't behave as we want it to in long pipes, and that's an unknown, and it'll be a case of looking at, the lowest risk and how to deal with that. Also, we're not sure exactly how we're going to measure fugitive emissions for captured and stored CO2, but we are developing those techniques. And I think finally we're not sure exactly what uncertainties will be achievable in monitoring and verification, but we will find a number, and we'll have to apply it until we can better it. I think probably the biggest question, going back to the earlier slide, is what happens when we scale this up to a full-size plant, because we really don't know exactly how it will behave, because we've quite simply not done it before, but we will do it in the next 5 years. And then to really keep uncertainties low, we need to do some standardisation or more standardisation, and that's a procedure for monitoring of capture plants, and that would be the capture efficiency, and related to that, any amine degradation products. We need a procedure for whole system CO2 accounting, and flow monitoring for gases and liquids applied to carbon capture and storage and transportation. I think one thing that's been mentioned here is acceptance criteria for CO2-rich gases and what contaminants we can live with. We already have some to go on from enhanced oil recovery and the specifications for those, but we haven't specified what that is. But I think we have, certainly the bricks in place, if not the foundations. For example, we've talked about corrosive gases, and some specifications for moisture already range between 160 ppm and 500 ppm, depending on the pressure of gases and liquids and how cold they're going to be. So we know how to measure those, and we just need to apply what we've done so far in other fields to carbon transportation. Related to that, how and when we determine gas composition, because again, it's time consuming, it could be expensive. So what's the minimum we can do to make sure that we're keeping risks as low as acceptable? If you need to contact me, contact details are there.